Welcome, Geometry iPad Initiative students. This is Mr. Lane again for another fun and exciting lesson over section 4.7, which is Introductions to Coordinate Proofs. We're not going to be actually proving a whole lot. We're going to be setting up different shapes, objects, in order to prove them later. But we're going to take a look at just the initial setup in it today. Make sure that you read through the objective, the why. Make sure that you answer number 5 in your notes to get full credit, and be paying attention for that secret word of the day. So hopefully you're the first one to get it. Send it to me and get those 2 points. So let's get moving in today's lesson. What a coordinate proof is a style of proof that uses coordinates, geometry, and algebra. So it's going to incorporate a lot of algebra into this. The shapes that we talk about, squares, rectangles, so on and so forth, is the geometry part of it. And we're going to be doing it in the coordinate plane. So the steps to position the figure in a plane, we have a few different strategies. Number 1, we can use the origin as a vertex, keeping the figure in quadrant 1. It's always a nice strategy to use, keeps things simple. We can also try and figure the center the figure at the origin. We could center a side of the figure at the origin, or we can use one or both axes as sides of the figure. So whichever one works out best for us for each individual problem is why we want to approach it. Well, let's start taking a look at what we're going to be doing in this section. The first example shows up here. It says position a square. Now hopefully you know about a square already, that each side length is going to be the same. We're going to be having 4 90-degree angles with sides length of 6 in the coordinate plane. So that doesn't sound too bad. Let's get a little coordinate plane up here real quick. Stretch this across there, stretch this across there. Perfect. And what we're going to do is we're just going to center, or we're going to put one vertex right at the origin. So we're going to first off just mark that point A here at the origin. So that means that over here 6, we're going to put another point, and then we're going to go up 6. And we're going to put another point. We're going to call this one B. So if we go 6 over from B, right here, we're going to get C, and we're going to call this D. So now we've got a square. We're just going to connect the dots real quick here, and we're going to list those vertices so that everybody knows how we came up with this square. So vertice B would be at 0, 6. C is going to be at 6, 6. D is going to be at 6, 0, and then A is going to be at 0, 0. So now we have our square in the coordinate plane. Position a right triangle with leg lengths of 2 and 4 units in the coordinate plane. Hint, use the origin as the vertex of the right angle. So we're going to go ahead and follow that hint. We're going to get our coordinate plane up here, and we're going to put A right here. So now we want the legs to be, one of them to be 2, so we're going to call B right here. And then we want the other one, it says, to be 4. So we're going to put C right here. And then we're going to go ahead and connect those dots real quick. Just like so. And we're going to go ahead and list those vertices. So B is at 0, 2. A is at 0, 0. And then C would be at 4, 0. So we're just positioning things in the coordinate plane like the questions are asking us. Regular geometry students, you'd be doing 2, 3, 8, 9 at this time. iPad students, we're going to move on here real quick. It says write a coordinate proof. It says given that the rectangle ABCD with these vertices, so we're going to mark those vertices real quick. A is at the origin. B is at 4, 0, so we're going to count 1, 2, 3, 4. We're going to mark B B right here. C is at 410, so I know this last one way up here is 410, and then at 0, 10, so right straight above here 10 would be our D. And it wants to show that these, let's go ahead and connect this square together. It wants to show that the diagonals, and what diagonals do is they're a segment that goes from opposite vertices, so from like A to C here would be a diagonal, and then from B to D would be a diagonal also. So it wants us to see if they bisect each other. So what we can do is we can just figure out if the midpoints of each one of these segments matches up. So we need to find the midpoint of BD and see if it's the same midpoint as AC, and if it is, then they're going to bisect each other. Okay, so let's put midpoint formula up here if you forgot it. So midpoint is equal to the average of the x's, so we're going to take x1 plus x2 and we're going to divide that by 2, and then we're going to take the average of the y's, which is y1 plus y2 divided by 2, and we're going to go ahead and plug this out. So we want b, which is 4 plus, I'm going to slap in the 0 over here for my y, and then we want d, which will be 0 for the x and 10 for the y. So let's see, when I add those and divide by 2, I would have 4 divided by 2, which is 2, and I'd have 10 divided by 2, which is 5. So that would mean that the midpoint of BD would be 2, 5. Now we got to make sure that the midpoint of AC is 2, 5, and if so, then those two are going to bisect each other. So plugging AC into the formula, let's see, my A is 0, 0, so I'm just going to go ahead and plug those in real quick, like so. And I've got the formula set up on both sides, so I can just look at my C here, which my X is 4, and my Y is 10. So 4 divided by 2 again is 2, and 10 divided by 2 is 5. So notice that the midpoints are the same. So those two are going to bisect each other. So very good. Let's move on. Regular geometry class 4 and 10 at this time. iPad class, yours will always be at the end of the lesson. Click on it in the Lumen Touch website. Let's see, it says position each figure in the coordinate plane and give the coordinates of each vertex. It says a rectangle with width m and the length is twice of the width. So let's go ahead and get our coordinate plane up here. And I believe I can just put this rectangle with the center point, or one of the vertices, right at the origin again. And if I mark, let's see, the width, it says is m. So I'm going to come over here and I'm just going to mark this m for this coordinate right here. And then, well, if that's m, I would go 2 m's to get up here then. And the hard point would be this point, but I go m over and 2m up. So the coordinates of this point would be m for the x, 2m for the y. The coordinates of this point would be m, 0, and of course the origin would be 0, 0. And then this point up here is just straight up 2m, so that would be 0, 2m. Okay, and then we have another example here. It says a right triangle with legs of length S and T. So I'm going to kind of use the same technique as we did earlier with the right triangle. I'm going to stick the right angle right at the origin again. So right here we could call that A if we wanted to. And then up here we need a length S, and then over here we need a length T. And then we need to write the coordinates of these 3 points to form our triangle. So I'm going to go ahead and connect them real quick. Bam. We got our triangle. Let's list the coordinates. If I go straight up S, that would be 0, S. If I go straight over T, that would be T, 0. And the origin, as always, is 0, 0. So we're just coming up with the coordinates of each vertex, and we're calling that good. So we got 5, 6, 11, and 12 for the regular geometry class, and that looks like it's going to wrap it up. We can rewind this, look for the secret word, but the secret word for today is phone. Phone is the secret word for today. Yes, I did just look at my phone. And yes, this is at the end, so somebody's probably going to look and find this pretty quick. But this is Mr. Lane signing off from OHS High School. Catch you next time.